Alright, hello everybody. In this video, we're going to be learning about some advanced topics on pointers, alright? Not super advanced, but we're gonna go a little bit more in depth, just a little bit. Some additional stuff I want to show you, right? So we're gonna do the most cliche thing ever, and we're gonna declare a variable, x. Okay, and we'll do int x equals 69, okay? And we're gonna go ahead and declare a pointer, right? So we're gonna make it a int what x with a asterisk, right? This indicates it's a pointer, and we'll name it a pointer. There we go. Whatever, x pointer. Okay, and we'll just set it like that. We'll run our code. Absolutely nothing is gonna happen. It's all good. So now let's go ahead and see out our x variable. What's that gonna output? 69, right? Now let's go ahead output what? X. Ooh, actually, we need to do what? Do it all in one line like that. Much better, right? Go ahead, click run, and it's gonna give us a hexadecimal return answer, right? Because this is the memory address, something humans don't understand, but whatever. All right. But did you know from this pointer, right? This doesn't just store the memory address, it also holds the number 69. So if we use an asterisk like that, it's gonna equal 69. It's pretty confusing, but right now, x pointer, right? Int x pointer equals this. It's holding the memory address of x, right? So it's this hexadecimal. But if we want to reference back to the original value of x, we can put this asterisk, and it'll give us 69. Pretty insane. Let's go ahead and try another thing, right? So we're gonna copy and paste this, and we'll make this 79, okay? And we have our x pointer. We'll name this y pointer, y, and we're gonna do x pointer plus asterisk y pointer, right? And what is it gonna do? It's literally gonna add up these two numbers. Whoops, I forgot to put y. It's gonna give us 148, right? So even though these are pointers, right? You know, if we remove the asterisk, it's gonna give us an error, you know? These aren't binary operators. But we put these, and it references back to the original value that it's pointing to, right? The integer 79, 69. So we can do math with this, right? This allows us to even divide it, right? We can even get, for example, user input. Let's make it a little bit more advanced. Enter x, okay? Sin x, okay? And after it gets x, so let me just do this here. X doesn't need a value. Y doesn't also need a value. Y. Alright, just wait. I'm almost done. Alright, so what does this allow us? It can enter two values. It will store the memory address for both of them in here, in these two values, and then we can also do math with them. Let's do, oh, whoops. I forgot an easy mistake. Let's do, wow. Let's do 2 and 9. Ooh, there is a problem. Why is there a problem? Let's find out. 9 divided by 3. There we go. So we should maybe store this in a float. Let's go ahead and give another try. Float. Answer equals x divided by y. And we'll just see out answer. And to make this more convenient, we can do just y. Perfect. Display the answer. So what does this do? Store the memory address of X into this pointer, right? And what else? Of Y into this pointer. And now, what is it gonna do? Ooh. Let's do this, right? X pointer with a asterisk. And you might be thinking, one obvious way you'll be like, why will this ever be useful? But that's just life, long story short. You'll be using pointers a lot. It's good for memory efficiency when you're working with big programs. That's definitely one way of thinking about it. You can see, okay, so if we did that, right, this would give us a comment, right? And so we should need to space it out. Good thing we saw that. Let's go ahead and give another try. So as you can see, we're using pointers. So let's use 7 and 49, or the other way around. There you go, gives us 7, nice. But yeah, that's how pointers work. This is some more advanced little bit on pointers, how you can use them in mathematical equations, calculations. But next lecture, and from there, we'll be showing how you can use memories to pointers to actually speed up your programs and take out useless garbage memory that you don't need. All right, I want to thank you for watching, and I'll see you in the next lecture.